I'm a mathematics PhD student, and I've recently started using ChatGPT pretty regularly in my research. And I thought I would make a video sort of showing some use cases for this. So about 2 weeks ago, I made a video pointing out that the rate of kind of improvements to things like ChatGPT is pretty fast, and this will probably lead to some disruption in kind of academia. And some kind of pushback I got from that video was that you're kind of saying that ChatGPT is better than it kind of currently is. And so I thought I would make a video just kind of showing that, well, from my use case, it's definitely good enough and is very helpful. So I'll now kind of describe the problem that I had. So the kind of the research question that I had was I was thinking about curves, say like gamma, in a three-manifold Y. So and what I wanted to say was that so basically the idea is we have some three-dimensional space and then we have some closed loop inside it. So this will be a knot in the three-manifold. So this is a terrible drawing. So this is gamma, and this is a map from, say, S1, which is the circle, into Y. And let's say I have a function f, which is from Y to R, and f is in the subleft space L21. Then what I want to know is, can I bound the exponential of the integral over gamma of f? Is this less than some function of the L2 norm? And so this is kind of equivalent to saying that the L1 norm of f restricted to gamma L1 of gamma, is this less than some function of the L21 norm over gamma? So this is what I wanted to know. And so there are results kind of going into this, that if you have L21, or say like 1 plus delta, where delta is some small constant, then this space embeds into L2 of, I think it's delta over 2 R1. Alright, so this is a known result. And so what I'm saying is, okay, what about the edge case where delta is equal to 0? So this embedding result doesn't hold in this case. But maybe if I restrict this exponent, then maybe I can get some other result. And so I asked my supervisor about this, and he said, yeah, it seems like a reasonable thing that you can do. So maybe do that. Maybe email another professor who's functional analysis expert, and then see what he says. So I did that, and then he said the proof of this result can probably be generalized to to the case where the exponent is less than 2, and then you can prove the embedding. So basically, if you have this result, then you can kind of do this argument kind of locally, splitting up the curve, and then you'll get some embedding result. So that's what I set out to do with ChatGPT, and then now I'll show you kind of what I asked ChatGPT and how that helped. Okay, so the first thing I asked ChatGPT was to prove the original result. So I needed to know how to prove the Sobolev embedding. So prove the sublab. I'll say trace embedding theorem L2 so S of. I'll restrict to of the specific example that I have in mind here. Just to make things a bit easier. I think when I was doing it, I maybe had slightly more general queries. But let's just see what it says. So this is the 4.0 model. This is the not the paid for one. And so it's suggesting to use the Fourier transform, which is the correct way of proving this. This is another way of describing the norm. I don't really know what it's talking about here, so it's saying something about restricting the function to R2, but we want this function to be restricted to R, so I don't know what it's talking about. So then consider the Fourier transform, sure. Then it's saying take the Fourier transform with a restriction. And then I don't really understand what this is saying here. I think that this is kind of the right ideas, but I think it's not. It's doing okay, but it's a bit confused with what it wants to do. So maybe this does work. So this is saying we're going to restrict it to the restriction from the space, but I don't think this works. This argument is wrong, because it's saying first restrict to R2, so use the standard trace argument to restrict to R2, and then restrict to R3. This doesn't work because you're going to get a restriction to h to the 1/2, which will be 2, and then you don't have a trace theorem for h to the 1/2 to the line, or like a half plus delta. That doesn't work. So let's try asking O1 to prove this. Let's see what it does. So this is again thinking of doing this, the same idea of restricting and then restricting again. So this is one way of doing it with this method, but it's not kind of like an optimal way of doing it. So let's see what the answer it gets. So I think this is correct. This is the correct thing to do. And I think this is the correct answer that you should get. And is it proving it in the right way? Yeah. So I think this is. So I think this is the correct way of doing it. I'm just a little bit confused. Okay, so this function u, this isn't the original. so this notation is a bit confused because there's still an element of kind of Fourier transform going on here. This is not quite right. I think this is the correct expression that you should have, and then yeah, this is right. This is the right way to approach this problem. And then this is correct, and yeah. So I think that this is a valid. Once you've got this step, it's basically obvious how to continue with the proof. And so it's got this. Interestingly, it does also have this s greater than 1 is sharp. I think when I was doing this proof for myself, I think I maybe used O3 and it didn't have this, the O1 model is perhaps a bit more, what does it say? Uses advanced reasoning. So this is maybe a bit better in some situations than O3. Yeah, so this doesn't quite, I don't know, I wasn't quite convinced that this is the case because you could maybe imagine doing something with, so in this step, you want this integral to converge, but you can also get convergence of this into, if you used Holder's inequality here, then you could potentially get convergence when s is equal to 1 of this integral, provided your Holder exponent was large enough, but then you would have to deal with this integral as well. So that was my idea on how to do that. But if you try and find a proof of this in the literature, it's actually quite difficult to find a proof. I do have a reference that proves this for Bezov spaces, which is a more general result, but from kind of my point of view, if I want a kind of simpler result, this is better than that. Okay. Since I was pretty convinced that this result is actually true, due to the email that I got, email correspondence with the professor, I was thinking that this result can probably be generalized by doing some different analysis in this step. So I was thinking that if I apply Holder's inequality here, then I can reduce the requirement on s to be, I can set s equal to 1 and then somehow handle this integral. So that was my idea, and then I then spent a few, spent some time thinking about that, and then I didn't really get anywhere. So I had asked ChatGPT a load of things, maybe restricting the problem to being kind of more about, the actual situation that I was considering, and I was going around in circles a bit. So ChatGPT wasn't helping there. But then what I did was I just asked it, I thought, well, maybe this result isn't true. So what I asked was talking about, so if you have a subleft function, then it's not defined kind of point-wise. You can, subleft functions are defined up to sort of almost everywhere equivalence. So if you're restricting to a submanifold, which is of measure 0, then you have to kind of come up with a way of defining the restriction. So the way that this is done is you don't have a definition point-wise, but you have a definition of the integral over any set of positive measure. So what you do is you have a sequence of sets where the volume goes to 0, each containing the point that you're interested in, and then you just take the limit as the volume goes to 0, and that's kind of a way to define the function point-wise. So if you have an L21 function, then these limits will be, this kind of method of defining this function point-wise will work almost everywhere. And so if you want to restrict it to a line, then you generate a function on the line by doing a similar procedure to this. So I asked sort of ChatGPT about this. And so what I was asking was, if I have an L21 function, can I define some sort of function on the line just from L21? So in R3, almost everywhere, L21 can be, a function in L21 defines a function kind of point-wise almost everywhere. But it could be the case that along the line, this is a set of measure 0. So maybe everywhere on this line, the function isn't defined. So, you can't define a restriction of the function to the line. So that's what I asked about it. And I was using O3 Mini for this. So it then reasoned for 18 seconds and then said, no, probably not. And it gave some motivation for saying no, based on, kind of what I've just said there, where you have it's kind of like a measure theoretic problems. And then it said that, yeah, you can average over things. So then it said in summary, well, some functions you can define on this manifold, so in summary, there exist functions where you can't define the trace on a one-dimensional manifold. So then I just asked it for a counterexample, see whether it could come up with a counterexample. And it gave this example, which turns out to be correct. So this is a function which doesn't have a limit on the, where you restrict to the line r equals 0. This limit doesn't exist because the function kind of oscillates as you get there. And so it doesn't make sense to define, it doesn't make sense to define this function at r equals 0 by this kind of limiting process where you're shrinking sets and, integrating over a set and then taking that to be measure 0. Basically, you can pick, as your volume decreases, then the integral divided by the integral of the function divided by the volume oscillates as well. And so this is a good example. And so this is how ChatGPT has proven that the claim that I was trying to make isn't true. So you can't, it doesn't make sense to define an L1 function. There isn't an embedding of L21 into L1 on the curve. And so you can't necessarily bound the exponential. It hasn't completely solved the problem though, because this is a bounded function, but I'm pretty sure that you can come up with an example where, if you just multiply by some function that's tending to infinity, then you can get an L2 integrable function. If the function is going to infinity sufficiently slowly, then you can get these limits sort of diverging. And in that case, then you won't be able to bound the exponential of the integral of the function. Although this isn't this isn't the most complicated theorem, it was still much quicker using ChatGPT than it would have been me trying to come up with it. And it's also, ChatGPT is right, whereas my supervisor and the person who I asked were wrong about this. So even if, I don't know, you have kind of intuitions for things, asking ChatGPT is kind of like a good way to think through the problems. And then it also gives really very reasonable output. So you still have to check through it quite thoroughly, but it does come up with ideas. and it is very useful. I think also the way that you write the prompts, because basically the way that it works is it reads what you've written and then thinks of something that would be reasonable to come after that. The way that you write the prompts is quite important to get it to give you good answers. So I always kind of write LaTeX in the prompt and have like asking sort of reasonable questions that aren't too general. So it kind of, the responses that it gives are kind of appropriate for the kind of, the tone of the question that's been asked. And I think that's really important. So, if you write kind of sloppy prompts, then the answers that it gives you are probably going to be not very good, because it doesn't think, it doesn't think that you're asking a very sensible question, or you're not asking a question in a very precise way. So I think, asking very precise questions is really the way to get kind of the most out of ChatGPT. Use ChatGPT for research or just kind of general job things, then feel free to write in the comments about your experience with that. I'm planning on making some other videos about kind of AI and kind of more kind of societal implications. So if you're interested in this, then maybe consider subscribing. Thanks for watching.